So, Bismillahirrahmanirrahim. Okay, so today our talk will be about one of the highly useful and techniques nowadays in the chromatography. That's called as HPLC. इसका मतलब है high performance liquid chromatography. It's also called a high pressure liquid chromatography. Now, two words: high pressure. So it's something like to do with a high pressure, a high performance, and that is LC, that's a liquid chromatography. जैसे मैंने लास्ट क्लास में हमने कहा था, सो प्लीज गो थ्रू दैट, कि उसमें हमने कहा था लिक्विड क्रोमेटोग्राफी में इन जनरल वी कैन टेक बेस्ट एग्जांपल ऑफ कॉलम क्रोमेटोग्राफी, क्योंकि हम वो लैब में भी करते हैं और बहुत कॉमन है. तो उसमें द मोबाइल फेज इज अ लिक्विड, usually polar, non-polar solvents, and stationary phase is silica gel alumina. So this is actually the same. It's basically HPLC is a liquid chromatography, is similar to say the basics as in the column chromatography, but then there is additional thing that is high pressure or high performance. Okay, so basically high performance. So it's a high performance technique. High performance technique. Performance technique. So it's a high performance liquid chromatography, which is improved form of the column chromatography. जब मैं पहले कहा था improved form, so that's why it is a high performance. So अब इसमें क्या होता है, जैसे नॉर्मल क्रोमेटोग्राफी मैंने बोला था कि just this is your column, then this is packed with the stationary phase, then you allow your mobile phase to flow through, drip through under the gravity without any external pressure, and then when you have the samples inserted inside, so they will get separated based upon their interaction with the stationary and mobile phase. So it's similar to that, but in this case, the solvent in the high performance, it's called high performance. Why? Because the solvent, the mobile phase, it's basically it's forced through high pressure. So it's forced through high pressure. So mobile phase. So your mobile phase is forced through high pressure, around 400 atmospheres. So that's 400 atmospheres. That means the process, this HPLC method is very fast. Right? So we can say, so this is very fast. You can do many separations in less time, and you can do them in an effective way. Now let's move further. This is point number one. We use high pressure. The solvent mobile phase is forced through the stationary phase. Otherwise, it is actually the column chromatography, the liquid chromatography. This is point number one, that the mobile phase is actually, it flows under high pressure around 400 atmospheres. Number two, जो दूसरा डिफरेंस में होता है कंपेयर टू कॉलम क्रोमेटोग्राफी, इट इज दैट कि जो स्टेशनरी फेज हमने कहा था कॉलम क्रोमेटोग्राफी में, स्टेशनरी फेज इज usually the silica particle, silica gel, or the alumina. Now in this case we have the much smaller size of the particles. The particle size is smaller, very important. So in HPLC, particle size of adsorbent or particle size of the stationary phase. So the particle size of stationary phase is smaller. Stationary phase, that is small. So the particle size of stationary phase is smaller. Now what that does, हमें पता है जब भी particle size small है, that means surface area is more. ठीक, we'll get more surface area. That means surface area is more now available in the column. So surface area is now more in the column. इसका मतलब हमारा sample during the, जब हम ऐड करते हैं इसमें sample, that has more surface area to get absorbed with the surface, or I can say there will be more interactions between the stationary phase and the components of the sample. जब more surface area, more interactions है, that means up now it will be have better separation. So this will give us better separation. Effective separation of chemical compounds from a sample. So because of high pressure, it's a fast process, quick time. Because of the fine size particle of the stationary phase, it gets more surface area, there's more interactions with this component, that's a better separation. Number two, so that's why the ये दो main points है as far as the stationary phase and mobile phase है, are concerned in the HPLC compared to the other chromatography techniques. Now, if we see other things, what are there are some improved things in the chromatography. So then we have to look at the term called as the normal phase. So we'll understand normal. मैंने पहले भी डिस्कस किया था एक लेक्चर में. Normal phase. So we'll understand normal phase, HPLC. Okay? And then we have one more term, that's reverse phase. So first we'll go to normal. Normal phase means usually chromatography में, usual chromatography में हमारा जो ये packing material होता है, that is silica gel and that's polar. So usually we have our stationary phase, that's polar, high polar. और जब सॉल्वेंट यूज करते हैं, जब मैंने उस टाइम पे भी कहा था कॉलम क्रोमेटोग्राफी में लास्ट लेक्चर में, मैंने कहा था दैट इज वी यूज हेक्सेन यूजुअली लेस पोलर सॉल्ट्स, देन जितना हमें रिक्वायरमेंट है उस हिसाब से वी कैन इंक्रीज द पोलैरिटी. सो दिस इज अवर स्टेशनरी फेज, दैट्स पोलर यूजुअली, एंड मोबाइल फेज, so that is your non-polar, let's say hexiene, usually it is hexiene, suitable भी रहता है. So it is your non-polar, fine. Now this type of chromatography where we use the polar adsorbent, or we pack the column with the polar stationary phase like the silica gel, and the solvent, or that is the hexane, which is non-polar, and then you have a column and you have a column, yes, usually in the column chromatography. So what does that mean? That means if you have two components, let us say 1 and 2, and let us say components are polar. So this is more polar, I will write P1 is more polarity than P2. So both have polarity. As they have polarity, our adsorbent is polar. That means once we insert our sample here, they will stick more to the column. They will adhere to the column because they are more polar. So polar interacts with the stationary phase more. And when the solvent which is flowing through it, that is non-polar hexene. So that means they will take a lot of time to come through. बहुत टाइम लग जाएगा उनको नीचे आने में, क्योंकि they will not go, they will not be partitioned now in the non-polar phase. So it will take a lot of time. We can separate them, but it will take a lot of time. और हम ये कहेंगे कि in this case the polar compounds, they will take a lot of time to come down. अगर इन दो को कंपेयर करेंगे, since it is more polar, it will get more attached to the stationary phase, so that this will come first. So this will come first from the column, that's P2, followed by this. So we can separate this. This is called normal phase chromatography. But HPLC में usually we don't use this procedure. Whereas the column chromatography, we do work in this fashion. Okay. Now then we have one more term, that is which is actually present in the nowadays, that HPLC, that is the reverse phase condition. So this was the normal phase chromatography. Now we'll go to the reverse phase. Reverse phase column, that's the high performance liquid chromatography. तो बहुत simple है. Normal phase में our stationary phase is polar. Now our stationary phase is non-polar. Usually कि हम इस केस में क्या करते हैं, at this level, ज़्यादा इसमें डीप में नहीं जाएंगे, जो हमारा सिलिका जेल है इस पे हम केमिकल से मॉडिफिकेशन कर लेते हैं. That means we are basically modifying the surface. We are adhering some hydrocarbons, long chain hydrocarbons. Hydrocarbons, we know they are non-polar. In a stationary phase, now we have attached on the stationary phase the non-polar hydrocarbons. That means now the stationary phase is less polar, and we can say it is a non-polar. So that's number one. और solvents हम use क्या करते हैं? Mobile phase इसमें कौन सा use करते हैं? और mobile phase, they are polar compounds like water, like ethanol most commonly, and so on. So mobile phase we use like the methanol or alcohols or water. Fine. Now अगर यही sample हमारे पास है and we have this type of setup, we know this is more polar. That means now it will go into the mobile phase more, or it will go more into the stationary phase. Now stationary phase is because its surface is modified with non-polar compounds. That means now it will go into the mobile phase more. It is more partial in the mobile phase. That means this mobile phase is flowing through under high pressure. So this compound will come very fast. So we'll get compound P1 first. Then we'll get compound P2. And pressure is also high, so we'll get them very fast. So this is actually what is present in the high performance chromatography. So reverse phase HPLC is now most commonly used form. So this is actually now when I say the reverse, the HPLC, that means we're basically nowadays concentrating on the reverse phase high performance liquid chromatography. So ये तो थी in general terms. Now इसके अलावा चूंकि आप प्रेशर बहुत ज्यादा हाई यूज कर रहे हैं इस क्रोमेटोग्राफी में, ये कॉलम दैट शुड सस्टेन दिस हाई प्रेशर, so it is not the usual glass column. Now it is a stainless steel. This column is composed of stainless steel. तो और एक modification जो HPLC में है rather than the other chromatographies like column, the column is made of stainless steel, so as to sustain the high pressure of 400 atmospheres, so as to separate. So then in general HPLC we use basically this reverse HPLC method where we modify the stationary phase by the hydrocarbon, and then we have fine particle size, pressure of the solvent is high, so it's a fast process and we can do many things in less time and the effective way. But last point, जो यहाँ से जो components निकलते हैं, they are detected not usually जैसे हम वहाँ पे हम TLC method use करते हैं, यहाँ पे usually we use detectors, and वो detectors होते हैं UV visible detectors. They can be electrochemical also, like usually UV visible detectors. So we can check the peaks. We got a peaks through the chromatographs. We got a beautiful peaks, and the number of peaks will give us the number of compounds, and then use the time scale. So that will give us the idea about the polarity of the compounds. So this way we can basically check our components in the sample in a fast way. So we should say that HPLC is basically, it's an automated form. So HPLC is basically, it's a highly automated and extremely sensitive technique. Now, basic setup. Moving on to the basic setup of this HPLC. So this was in general the basic description of the chromatography. So what are the components or the instrumentation? If you look at the components of the instrumentation, so we'll start with the components of instrumentation. Instrumentation. HPLC. So now step number 1 we have, इसमें हम अपना solvent बना लेते हैं. This is the solvent reservoir. That is stationary phase. This is solvent reservoir. So component is solvent reservoir. Okay. Then this solvent reservoir, it flows with the help of pressure, some high pressure pump takes away the solvent from the reservoir, then some pressure pump. So it actually takes the solvent from this stationary phase with the help of high pressure, and then it's purchased into the column. Column के बारे में मैंने बोला था कि it is basically, now it's here packed with the very fine particle size silica, usually can be other also, alumina also, can be cellulose also. So then here we have a setup for the sample injection. So we have sample injection here. Let's say we have column here up to this. So this is sample injection from this point. Sample injection जिसको हमें separate करना है, इसमें बहुत सारे components हैं. So this is sample injection here, and then the solvent is allowed to flow from here to here. The solvent moves under high pressure क्योंकि pump से connected है. So from here we have the solvent moving with speed of under 400 atmospheres around. So it moves through high pressure. तो यहाँ से the components will come depending on कैसी polarity है. So let us see we have components coming down from here 1 to 70 eluting down from here. So they are basically detected with the help of a detector here. So मैंने कहा most commonly जो है that's UV visible detector. So detector is now we got the information connected to the computer. So we'll get a graph. So this is y-axis, that is your absorbance because UV visible based, and this is always a time scale. So two compounds means two peaks. So this is called as your chromatogram. So this is basically the basic setup of the instrumentation. This is the stationary phase prepared with then in a reservoir, then it's with a pump it's forced to the column where sample is injected, and then it's the column which is packed, and then its surface of the column it's made of steel से मैंने पहले ही कहा था to sustain the high pressure, and then the compounds will come to the help of UV visible detector. Will get a chromatogram. Now HPLC what we do now is that we have, so we're basically separating the components. Number one, so we can detect the components, so we can separate the number one, we can separate various components from a mixture. Various components, number one. With the help of UV detector, we can detect those compounds, which compounds they are. We can detect the components. Number third, we can also quantify them. Now, ये बहुत important. We can determine their concentrations also. अब तो ये बहुत advanced है. We can detect optical activity anyway, but that's not our level at the moment. So we can detect the concentration. Most three basic applications. We can separate the components, detect how many compounds are there, and which compounds are there, which species there, and what's the concentration of each species. उसके लिए हमें एक standard लेना पड़ता है, but anyway that's not our job at this level. So this was the basics of the high performance liquid chromatography. I believe this is enough at this level. This is all for the day. A quick question you, so you can please get me back here at this mail. मैं दोबारा बोलता हूँ क्योंकि it's very useful if you don't need any more topics to get prepared. I will try my best. That's all for the day. Stay